Hello everyone, myself Dr. NCH Ramgopal, working as Associate Professor in Mathematics in the Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. I welcome you all to today's presentation on Binomial Distribution Part 4. In the last session, we have introduced binomial distribution and we solved some problems on binomial distribution. We continue the same in this session also. Let us consider another problem. Out of 800 families with 5 children each, how many would you expect to have? 3 boys, 5 girls, 2 or 3 boys and at least 1 boy. So here, out of 800 families, this is the total number of families. We can consider this as total frequency. And each family is having 5 children. And out of 5 children, how many would you expect to have? 3 boys. Out of 5 children, 3 boys. What is the probability of getting 3 boys? And then out of 5 children, what is the probability of having 5 girls? And out of 5, 2 or 3 boys and at least 1 boy. So here the question is to find how many would you expect to have. That means in how many families there are 3 boys. That is the first question. In how many families there are 5 girls and so on. And now to find how many families are having 3 boys, first we need to find the probability of 3 boys. Then multiply this probability with total frequency. Let us denote it by capital N. And that capital N here given is 800. So first we need to find the probability of having 3 boys, 5 girls, 2 or 3 boys and at least 1 boy. After finding the probabilities, multiply with the total number of families. That gives the final answer. Now, as we know, by the binomial distribution, the probability of x successes is given by NCX p power x q power n minus x. And here n is the number of trials, x number of successes, p probability of success, q probability of failure. And n and p are the parameters of binomial distribution. If we have these 2 values, we can find all the required probabilities. And here we need to check out of 5 children, so n equal to 5. How many boys are there? The probability of 3 boys, probability of 5 girls and so on. So here first we need to define x. What is x? X is the success, number of successes. X denotes, for example, a boy, having a boy. If we consider boy as a success, then x denotes the number of boys. So simply here x is the number of boys, which is the success. And what is the probability of success, small p? Here we assume the equal probabilities for both boys and girls. For both boys and girls, we assume the equal probability. So probability of a boy is equal to probability of a girl is equal to 1 by 2. And we assume there are only 2 categories. In binomial distribution, that is one of the conditions. Outcomes must be mainly 2 only. So either success or failure. Here boy or a girl. If we consider boy is a success, then probability of a boy, that is 1 by 2. So which is the probability of success? If we have p, we can find q also 1 minus p, which is 1 minus 1 by 2, 1 by 2. So we have all these values so that we can use the definition of binomial distribution and we can find the corresponding probabilities. So here by the binomial distribution, probability of x successes is given by NCX p power x q power n minus x. Here it is given n equal to 5 and x is the number of boys which we consider as success. So the probability of success is probability of a boy, which is 1 by 2. Then q is 1 by 2, since q is 1 minus p. And now total number of families, that is also given. Number of families is 800. Now in the first question we need to calculate the probability of 3 boys. So here x denotes the number of boys. So probability of x equal to 3. Out of 5 children, 5C3, probability of success is 1 by 2 power 3 and failure is 1 by 2 power 2. So this is 5 factorial into 3 factorial into 5 minus 3 2 factorial, 1 by 2 cube and 1 by 2 square. So after finding this value, after simplifying, we get 5 by 16. So this is the probability of a family having 3 boys. But we need to find the number of families. Therefore, number of families with 3 boys is given by probability of x equal to 3 multiplied by 800. So 5 by 16 multiplied by 800. This 16 here 5 times, so 50 times, so 250. That means 250 families are having 3 boys. In 250 families there are 3 boys. That means the remaining 2 are girls. Now coming to the second question, first we need to find the probability of a family having 5 girls. So probability of 5 girls. But here what is x? X denotes the number of boys. If all 5 children are girls, that means there is no boy. So the value of x here is x equal to 0. Out of 5 children, 5c 0, 1 by 2 power 0, 1 by 2 power 5. So this is 1 into 1 into 1 by 32. So the answer is 1 by 32. And therefore the number of families with 5 girls is given by probability of x equal to 0 multiplied by 800. So 1 by 32 into 800, which results as 25. In 25 families there is no single boy. All the children are girls. Similarly, coming to the third one, 2 or 3 boys. The third question, probability of 2 or 3 boys. So that is probability of x equal to 2, or means plus probability of x equal to 3. So we can consider the families with 2 boys or 3 boys. So probability of x equal to 2, just now we have calculated. No, 3 boys we have calculated. That answer we have here, the first question 5 by 16. Okay, let us calculate again. So 5c2 into 1 by 2 power 2 into 1 by 2 power 5 minus 2 is 3, plus 5c3 into half power 3 into half power 5 minus 3 is 2. So after calculating the values here, this is 5 factorial by 2 factorial into 3 factorial, 1 by 2 square, 1 by 2 power 3, plus 5 factorial into 3 factorial into 2 factorial, 1 by 2 square into 2 cube into 1 by 2 square. So here 1 by 2 square into 2 cube means 2 power 5 common, and here 5 factorial can be written as 5 into 4 into 3 factorial, which will be cancelled with the denominator by 2, plus 5 into 4 by 2. So this is 1 by 2 power 5 into 2 times 10, again the same, 10 plus 10, 20. So 20 divided by 32, and we need to 5 by 8. We need to find the number of families with 2 or 3 boys is given by probability of 2 or 3 boys multiplied by total number of families 800. 5 by 8 into 800. So in 500 families there are either 2 boys or 3 boys. At least means probability of at least 1 boy. That means probability of x greater than or equal to 1. At least 1 boy means minimum 1 boy. So either 1 or 2 or 3 or all children are boys. Instead of finding all those values, we will calculate 1 minus probability of x less than 1. And here this is 1 minus x less than 1 means x equal to 0. No boys. So that one already calculated here as 5 girls. So the probability is 1 by 32, which is 31 by 32. Therefore, number of families with at least one boy is given by 31 by 32 into total number of families 800. So the answer is 775. Simply, already we have calculated the number of families having 5 girls is 25. So in all the remaining families there will be at least one boy. So simply we can calculate using this second problem itself. So total number of families 800 minus, simply 800 minus 25, which is 775. In 775 families there are at least one boy. Now coming to the next question, in a binomial distribution consisting of 5 independent trials, so it is given n equal to 5. Probabilities of 1 and 2 successes are given respectively. So the probability of one success is given 0.4096 and probability of 2 successes is also given 0.2048. Find the parameter P of the distribution. So find the probability of success that is given, and we can find this probability of P using the binomial recurrence relation. So the recurrence relation in binomial distribution is probability of x plus 1 successes is given by n minus x by x plus 1 into p by q into probability of x successes, which we have discussed in the part 1, binomial distribution part 1. The recurrence relation in binomial distribution is given by the probability of x plus 1 successes is equal to n minus x by x plus 1 multiplied by p by q multiplied by probability of x successes. So if we have x successes, we can find x plus 1 successes. For example, 0 successes. If we have 0 successes, we can find probability of, if we have 0 successes, we can find the probability of 1 success. Similarly, using probability of 1 success, we can find probability of 2 successes and so on. And here we can rewrite this as probability of x plus 1 divided by probability of x is n minus x by x plus 1 into p by q. And now probability of x equal to 1 and x equal to 2, 1 and 2 successes are given in the problem. So put x equal to, here let us substitute all the values, put x equal to 1. If we substitute x equal to 1, probability of 2 successes by probability of 1 success is n minus x equal to 1 by 1 plus 1, 2 multiplied by p by q. So put x equal to 1, probability of 2 divided by probability of 1. So probability of 2 and 1 are given already. So substituting these values here, that implies probability of 2 is 0.2048 divided by 0.4096. These values are given in the problem, which is equal to, and given n equal to 5. So 5 minus 1 by 2 into p by q. So by simplifying this, we will get, let us simplify this, 5 minus 1, 4 by 2. So 2 into p by q is 1 minus p. So 1 minus p by 2p is 2. So after simplifying, we will get 5p equal to 1. So p equal to 1 by 5. So this is the probability of success out of 5 independent trials. Now similarly, there is another problem. 20% of items in a factory are defective. So the probability of defective items is given. Probability of defective item is 20%. That means 0.2. Find the probability that in a sample of 5 selected at random, so n equal to 5, the number of trials, and by the binomial distribution, the probability of x successes is given by n c x p power x q power n minus x. Now in the first question, here n is 5. So 5cx, 0.2 power x and 0.8 power 5 minus x. So if we consider this as small p 0.2, q will be 0.8. We use these two values, because since we need to find the probability regarding the defective items only, we will consider x the random variable which denotes the number of defective items. Hence p is the probability of defective item, 0.2 given. And now the first question, probability of none is defective. None is defective. That means 0 defective items. Out of 5, 0 defective items. 5C 0, probability of defective item is 0.2 power 0, 0.8 power 5. So this is 1, 1, and the answer is, after calculating, we will get the probability of no defective items is 0.32768. And second, one defective item. So out of 5, one defective item with probability of defective item is 0.2 and 0.8 power 4. So again, this is 5 into 0.2 into 0.8 power 4. After calculating, we get 0.4096. And the third, 1 less than x less than 4. Since it is a discrete probability distribution, strictly less than is different from less than or equal to. So here strictly less than is given, so we need to consider only the values between 1 and 4. So x equal to 2 plus x equal to 3. That means 5C2, 0.2 power 2, 0.8 power 3 plus 5C3, 0.2 power 3, 0.8 power 2. So after calculating these two values, we will get the probability as 0.256. So simply using the formula of binomial distribution, NCX p power x q power n minus x, we can find the probability of x successes. And here n and p are the main values of binomial distribution, which are called the parameters of binomial distribution. If we know n and p, we can calculate the probability of any number of successes. And summary of today's session. Today we have discussed some problems on binomial distribution, different types, and then in the next session we will discuss fitting a binomial distribution. So to fit a binomial distribution to the given frequency distribution table. So a frequency distribution table will be given. We need to fit a binomial distribution for the given frequency distribution. Thank you.